this is Lori, and this is my homework for Paul McWhorter's Pico W course. We're on lesson 57, where we worked on calibrating our joystick. And in this lesson, Paul asked us to use the joystick to calculate the angle that the joystick was at, depending on how we were pushing it around. So that was pretty intriguing. Let's see what I did. All right, I have my setup over here, my joystick, and then I've added in my NeoPixel ring that I've used before, because I figured if we're talking about the angle around a circle, then, lighting up the NeoPixel that goes with that angle, just seems natural. The other thing I've got out here is I have a rotary encoder. I've got one connected up to my Pico as well. We haven't used rotary encoders in the course so far, but I'm going to do a second program with the rotary encoder, because the rotary encoder is kind of a natural thing when you're talking about something moving in a circle. And if I was using the joystick to move a NeoPixel or move them around this circle, I don't think I'd use a joystick. I think I'd use this rotary encoder. So I'll show you how I did, how I used the rotary encoder as well. But I'll do the first homework using the joystick as Paul requested. All right, so I'm going to import the modules. I'll need some things from the math, especially the arctangent and pi, to calculate the angle based on the x and y value from the potentiometers in the joystick, and then convert that'll come back as radians, and I'll need to switch it back into degrees. So I'm going to use the pi built into the math, and also the square root function, and setting up my NeoPixel ring. I am using a different library here that I found and used in the past. It has a little more functionality. Set up the joystick as we have, and I showed you this map range function in my homework as well, just kind of automating the math part of it that Paul goes through and shows us how to do. And then I've defined a little function to figure out which pixel, based on the angle you give it, should be lit on your ring. And it doesn't assume a particular size ring, so I kind of tried to make this a little more flexible. So it gets the number of pixels that are on the NeoPixel object, and then it figures out, how much of the circle each pixel is going to represent, how many degrees. So it's 360 divided by the number of pixels, and then using that to figure out which pixel we should light, and based on that angle that is given, and going ahead and lighting that. All right, so going into the while true loop, we're going to read our potentiometers from the joystick. I'm going to map them to -100 to 100 like Paul was doing in the homework. And Paul also showed us, maybe you want to eliminate some of the kind of noisy numbers close to the 0, 0, or the origin as I was thinking of it. So it's kind of the distance from the origin. So long we don't exceed 10, because I made the range -100 to 100. We're just going to set that to 0 degrees. So kind of when we're not touching our joystick, it's just going to read 0 degrees, as you can see right now. And then I have it running, as you can see. And then so it'll do that part. Otherwise, it's going to figure out which quadrant sort of the Cartesian coordinate system from -100 to 100 in the x and -100 to 100 in y, which quadrant you're in, and then figure out the angle from that, and convert, use the arctangent function and convert that into the proper angle. Then we'll light that particular angle, and I'll print all that to the screen. So you can see it running right now. It's hopefully you can see the little green dot here, and I'll try to move it up. So let's move it up to about 90 degrees, and we can see that. Move it to 180, down to about 270. You can see it's kind of noisy, so maybe taking some noise out of it. I didn't like how fiddly it is to, like, if this is how I wanted to move it around, um, I just felt that, especially using a circle, I don't know. I just felt the rotary encoder might be a better way if that was my goal. If the goal is just to get this angle that your joystick is at, well, I guess that, that works. So that's what I did, and Control C will cut it off. And now I'll show you how I set up the rotary encoder to move the dot around the circle instead of using a joystick. So here's how I moved the lighted pixel using a rotary encoder rather than the joystick. So I will link to a episode that I created on my other channel for a project that used a rotary encoder, and that episode has some good discussion of how rotary encoders work and the library that I'm using here, how to set that up with your Pico. So if you're interested, you can take a look at that. Since I'm not going to go into the details of how rotary encoders work here. And then I'm going to use that NeoPixel library again that I discussed before. Set up the NeoPixel ring. And then here's how you set up a rotary encoder using the library that I have. You tell it what pins it's connected to, and then you tell it what the minimum value and maximum value you want to get out of your rotary encoder. So whenever I read it, I want it to read a number between 0 and 23. And then the other important thing is I want it to wrap. So as I'm coming around, when I get to 23, I want it to go back to 0. So you can turn rotary encoders around and around and around. So it'll just keep wrapping around. And if I go backwards or forwards, it'll keep wrapping through the numbers 0 to 23. Then we'll read the encoder for the first time and set val old to the current value. And we'll light that, whatever that turns out to be, we'll light that on the ring. Then when we come in the while true loop, we're going to read the encoder again, but we'll call this val new. And then if val old doesn't equal val new, then we've made a change. We've touched our rotary encoder, we've turned it, and we want to change which pixel is lit. And so it'll go through and light that pixel that's the new value and reset the old to the new, and do that pretty quickly. And I'll sit here and just kind of wait and read the encoder over and over again, and continue to move the pixel whenever we move the encoder. And then we can do a keyboard interrupt to leave. So a lot less code to put that together. And I think you'll also notice it runs pretty smoothly, much nicer than using the joystick to move the light around. All right, so we got that one here, and I'll kind of reach in with this hand and turn it. And you can see I'll go this way. You can see it going around. And if I go the other way, you can see it going around. So just very smooth. I really like how that works. So that's another way to do what I did with the joystick. And as I said, I think it's smoother and a little more precise too. A little harder to use the joystick to get a particular one of those NeoPixels to light. All right, well, that's my homework. I had a lot of fun, Paul. It was an interesting homework for us to work on, and I want to thank you for watching.